So in this video, we're going to go over the problems that are in the Unit 5 test review. So let's try rewriting this problem as a radical. So you can see here we have a rational exponent, right? So remember, the numerator will become the power, and then the denominator will become the index of the root. So let's try rewriting this. So this is now going to become the third root of this entire expression, 4x to the fifth y cubed squared, okay? So it's very important that you remember that this entire expression is what's being squared. So what I need to do now is I need to kind of like distribute this 2 to every term that's inside this expression. So this is going to become the cube root of 4 squared, and then x to the fifth squared, and then y cubed squared. So what's going to happen here is it's going to become the cube root of 4 squared is 16, and then x to the fifth squared. Remember, when I have a power of a power, I actually end up multiplying those together, right? So that a to the m to the n will become a to the m times n. So I have 16x to the 10th, and then I have y to the 6th. So this is now my fully simplified answer. So now let's try this problem. So here it wants me to find the cube root of 64, x to the 18th, y to the 30th. So I'm just going to separate this now. So I have the cube root of 64, the cube root of x to the 18th, and then the cube root of y to the 30th. So the cube root of 64, you can just use your powers chart for that. The cube root of 64 is actually 4. The cube root of x to the 18th, remember, I want to check if 18 is divisible by 3. If it is divisible by 3, I just go ahead and divide them. So that's going to give me x to the 6th. And then now here for y to the 30th, I just do, is 30 divisible by 3? And it is. So I just do 30 divided by 3, and that's going to give me y to the 10th. Okay, so 4x to the 6th, y to the 10th is my fully simplified answer. So now let's try this problem. So now we have a square root, right? We have 5 times the square root of 180, x to the 9th, y to the 20th. So I'm going to leave the 5 alone for right now. And then I'm going to work with simplifying each part of my square root. Okay, so I'm just going to separate all these pieces out. And so now I'm going to look at each one separately. So remember, what I need to do here is with 180, I need to figure out what is the biggest perfect square that evenly divides 180. And so if you use your squares chart, you'll see that the biggest perfect square that evenly divides 180 is 36. So then what I do is I do what is 180 divided by 36 on my calculator, and that tells me that that is 5. So what I have left under the square root is 5. So the square root of 36 is 6, so I can turn this into 6 times the square root of 5. So now I'm going to go over here. So here I have an x to the 9th. Remember that when we have a square root, the index is basically 2. So the next question I'm going to ask myself is 9 divisible by 2? 9 is not divisible by 2, so I need to break apart this x to the 9th and rewrite it as something that is the biggest number less than 9 that's still divisible by 2. So I'm going to rewrite this as the square root of x to the 8th times the square root of x to the 1. The square root of x to the 8th, well, what I just do is I take this 8 and divide it by that index 2 that we know we have. And so that becomes x to the 4th, and then I still have the square root of x under my square root. So now let's go to y to the 20th. 20 is divisible by 2. So I'm just going to take that 20 and divide it in half. So I'm just going to be left with y to the 10th. And don't forget this 5 that I had in front from right here. So what I do now, finally, when I write my answer is I just gather up all my terms. So I just collect everything that should be on the outside. So on the outside, I have 5 times 6 times x to the 4th times y to the 10th. Right, so I can just write that as 5 times 6 is 30, so I have 30x to the 4th, y to the 10th. And then everything else I'm going to leave under the square root. So under the square root, I have 5, and I have x, so that's the square root of 5x. So now this is the fully simplified form of the answer. Okay, so now let's try this problem. So here we have a cube root, so I'm going to use that strategy where I just take everything apart. So I have the cube root of 64, the cube root of x to the 12th, and the cube root of y to the 21st. So the cube root of 64, you can use your cubes chart for that. So the cube root of 64 is just 4. X to the 12th, I'm going to see if 12 is divisible by 3, and it is. So 12 divided by 3 is 4, so I have x to the 4th. 21, I'm going to check if it's divisible by 3, and since it is, I just do 21 divided by 3, and I get y to the 7th. So this is now my fully simplified answer. Okay, so now this is a complex numbers question. So it wants you to add and subtract all on the same problem. So the trick to doing these problems is just to take it 2 pieces at a time. So for example, I'm going to start off with just this 5 minus 3i minus 2 minus I. Okay, and then I'll worry about this plus 7 plus 3i a little bit later. So I start off with 5 minus 3i minus 2 minus I. Remember, when we're subtracting, what we're going to do is we're going to turn it into an addition, and then we're just going to distribute that negative, right? So that minus 2 is going to go here, and then the minus is going to go to I. So I have 5 minus 3I, and then plus, this will become negative 2 plus I. Okay, so when I like to add these, I just like to do them vertically, so I'm going to rewrite it like this. And when I do that, 5 minus 2 gives me 3, and then negative 3I plus I gives me minus 2I. Now I'm going to take this 3 minus 2I and combine it with the 7 plus 3I. So I have 3 minus 2I plus 7 plus 3I. Okay, so I'm just going to write everything all lined up. So I have 3 minus 2I and then 7 plus 3I. 3 plus 7 is 10. Minus 2I plus 3I, that's plus 1I. But remember, we usually don't write coefficients of 1, so I'm just going to write this as 10 plus I. Okay, so it says, what is the result when you multiply 7 minus 3I by its conjugate? So remember, conjugates are when we have a complex number like a plus bi, and then we have a minus bi, right? So it'll have the same terms, but just the opposite sign. So if we have 7 minus 3i, the conjugate is going to be actually 7 plus 3i. So there's two ways you can do this. You can go about using FOIL, or you can use that difference of squares property, right? So remember, we said that a minus b times a plus b equals a squared minus b squared. So we can use that here as a shortcut as long as we call a 7 and we call b 3i. So we're just going to say that this is 7 squared minus 3i squared. Okay, 7 squared is 49. 3i squared is going to end up being 3 squared I squared. So we have 49 minus, well, 3 squared is 9, right? And then remember that I squared is negative 1. So we have 49 minus negative 9, which will turn into 49 plus 9, which is equal to 58. If you use FOIL, you're still going to get the same answer. So we have first times first, so we have 49. Outside, we have 7, and then times 3i, so that's 21i. Minus 3i times 7, that's minus 21i. Minus 3i times plus 3i, and that's going to be minus 9i squared. So when I add up all my terms, I get 49 plus 21i minus 21i, and then minus 9i squared. So that's 49, and then notice these two terms are equal and opposite, so they cancel each other out. Minus 9i squared is like minus 9 times negative 1, so that's going to be 49 minus negative 9, which is once again equal to 58. So it doesn't matter which method. So in this problem, it says to write an expression that's equal to 3 square root of negative 75. So what I'm going to do first is I'm going to factor out that negative 1 under the square root, right? So this is 3 square root of negative 1 square root of 75. Well, the square root of negative 1 is I, so this is going to become 3i times the square root of 75. So now that I have that radical, the square root of 75, I want to check and see if I can make it better by factoring out a perfect square. The biggest perfect square that evenly divides 75 is 25. So I can turn this into the square root of 25 times the square root of 3. The square root of 25 is 5, so this is now going to become 5 times the square root of 3. So I have 3i times 5 times the square root of 3. And so you notice that I have a 3i and a 5 on the outside, so I can go ahead and multiply those together. When I multiply them together, I'm going to get 15i times the square root of 3, and that is now my fully simplified answer. So now let's try this problem. So we're going to simplify the imaginary part of this complex number. So I know it's a complex number because I have that negative under the square root. So I'm going to rewrite this as 6 plus or minus the square root of negative 1 times the square root of 45 over 3. So remember, the square root of negative 1 is equal to I, so I have 6 plus or minus I square root of 45 over 3. So now that I have that square root of 45, I want to see if I can make it better. The biggest perfect square that evenly divides 45 is actually 9, so I can rewrite this as the square root of 9 times the square root of 5. The square root of 9 is equal to 3, so we have 3 times the square root of 5 as the simplified version of the square root of 45. So now I'm going to rewrite this as 6 plus or minus I times 3 times the square root of 5, right? And that's all over 3. So to simplify this, I'm going to separate this into two separate fractions. So I have 6 over 3 plus or minus 3i square root of 5 over 3. Well, what's going to happen now is this 6 over 3 is going to become a 2, and then I have plus or minus, and this 3 and 3 cancel, so I have I times the square root of 5. So notice in this problem, it's only asking me for the simplified imaginary part, right? It's not asking me for the entire problem. So the simplified imaginary part is going to be just this. So I can just write that as I times the square root of 5. And that is my final answer.